This is a GCSE physics presentation looking at loudspeakers. To get started, describe what would happen when the current is switched on in the loop. Pause the presentation, come up with the best description as you can using as many sans words as possible, and when you're ready, you can continue on with the presentation. So pause now. What you should refer to is you should refer to the motor effect. You should refer to Fleming's left-hand rule. You should talk about the direction of magnetic field lines from north to south, and you should talk about the flow of current from positive to negative. And as a consequence, the pink side of the loop would move upwards, whereas the blue side would move downwards, and you would end up with a rotation. And the reason we've got a rotation is because of the split ring commutator at the bottom in yellow. And if you're not sure about that, if you don't recall that, go back and have a look at the presentation on motor effect before you go any further. In this particular lesson, we will have a very brief review of the motor effect, and we will of course go through how a loudspeaker works. Remember, the motor effect is all about when we place a wire in a magnetic field and put a current through that wire. And when we do that, there's a force exerted on the wire, and we can actually predict what direction a wire would move based on Fleming's left-hand rule. And that motion of a wire, because of the force that's exerted when the current is flowing through the wire and it's in a magnetic field, is known as the motor effect. Up to this point, most of what you've been covered in physics is going to be using bar magnets. What we also have is what's called a horseshoe magnet, and you can see the horseshoe magnet in the middle looks like the C shape. It has a north pole at one end and a south pole at the other end. Now, it doesn't have the same arrangement of magnetic field lines as you would find in a bar magnet, but there are still magnetic field lines going from north to south, and they will extend all the way out for as far as the magnetic field will stretch. Remember, the magnetic field is the area around a magnet which a non-magnetic object placed inside that particular area, the magnet exerts a force upon. In the picture on the left-hand side, you have a horseshoe magnet, you have a small metal bar, and you have a battery connected to the metal bar. You have to just assume that the metal bar can move in any direction at once and is not restricted by the wires. When you get Fleming's left-hand rule, and you have to use Fleming's left-hand rule, you have to remember to make the shape with your fingers and thumb in the correct fashion and then start lining things up, otherwise you're going to get totally confused. What I'd like you to do is have a go at using Fleming's left-hand rule to predict what will happen to the metal bar inside the magnet. Pause the presentation now, and when you're ready you can continue. Well, if you line up your fingers appropriately, you should have your first finger is the magnetic field line, which is pointing straight down from north to south. You should have your second finger, which is the current, which is going into the screen and is labeled C. And when you line those up, what you will find is that the motion will move the metal bar further in towards the magnet, so it will move to the left. The next question is, what two things can be changed to make the metal rod move the other way? So we've seen that with the current setup, the metal rod will move to the left. If we wanted it to move to the right, what would have to change? Pause the presentation, spend a maximum of 2 minutes trying to come up with an answer, and when you're ready you can restart. Well, the two things that we can do are, we can change the polarity or direction of current as it's also known. Either would be fine in the exam, or we can swap the magnetic poles around. So if we got that magnet and swapped it over, so south was at the top and north was at the bottom, we would have that pole rod move in the opposite direction. Up until this point, all of the diagrams have been using a battery to supply electricity to the metal rod. What would happen if we were to take that battery away, and instead of using the battery for the electricity, we use the mains for the electricity supply? Let me be very clear, do not attempt this, do not try this, do not in any way even consider this. It would be incredibly dangerous. You haven't got resistors or anything in that circuit, and it would be incredibly dangerous, so don't. But hypothetically, if we removed the battery and replaced it with mains, what would be different? Pause the presentation now and come up with an answer, maximum 2 minutes thinking time, and when you're ready you can restart the presentation. Well, if you were to supply electricity through the mains, we would switch from a DC supply, direct current from the battery, to an AC supply, an alternating current. That means that the current would continually be changing direction. And if we use Fleming's left-hand rule for the two different directions that the current can flow, you can see that in one direction, the current makes the metal rod move one way, to the left, but when we put the current in the other direction, it makes the metal rod move to the right. And what would essentially happen is the metal rod would move back and forth. And I would just have a continuous rocking motion backwards and forwards as the current went in one direction and the other. Now in a loudspeaker, it takes advantage of that flipping back and forward of current to make something move left and right. And if you look at the electromagnet, all we've done is replace the metal rod with a coil. Because we have a coil around a piece of metal, when we put a current through it, we have what's called an electromagnet. And what we can do is we can have that electromagnet, and it can interact with the magnet that's already there. And as a consequence, we can make, through the motor effect, that cone at the end on the right hand side, we can make it move right and left and vibrate back and forward. When we get it to vibrate back and forward, we generate what's called a longitudinal pressure wave, also known as a sound wave. And as a consequence, we can control how much current goes through the coil, and the amount of current going through the coil and the direction that it goes through the coil and how often it changes direction through the coil will determine what kind of sounds and pressure waves we are generating from that particular speaker. Just be careful in an exam. They can make some changes to the structure of the speaker, but the essential elements are always the same. You have to have a permanent magnet. You have to have some kind of coil with an electricity supply current flowing through it, and you always have to have some kind of cone or some kind of flat surface to create the pressure wave. Just to finish off, complete a learning triangle based on the presentation. So we're looking for 3 things you knew before you started that were mentioned during the lesson, 2 things you've learned from the lesson, and 1 thing you're still not sure about or a question to test yourself on later on.